Thank you, miss. Now you analyze again, likewise, the change of sign. Is positive, negative, one change of sign. Negative, negative, no. Negative, positive, yes. So n is equal to. And the number of real negative is 2 or 0. Because 2 minus 2 is 0. Do you understand that the MP of M, you subtracting 2, 4, 6, even number. When it's negative, have no sense. Then you stop in 0. So let's do in the table, the famous table that help me to understand using the Descartes rule, positive, negative, complex, and total. So we have this combination of 3. And this is 3 and 1. 3 and 1. Negative is 2 or 0. And complex, well, total is the degree is 9. The degree of the polynomial is 9. Therefore, we have 9 zeros or root. 9 is this. So this is 4. This is 4. Or this is 8. Because 8 plus 1 is 9. Okay, and this is the combination. So basically, the answer that they want is to say, can we have degree 9, 3 or 1, positive 0, and 2 or 0, negative 0, que es the option D. The option D in the package. Do you understand what packet we are talking about, no? The packet I sent before in the last lecture.
Yes.
Do you follow me for this or no? Do you want to projecting in the whiteboard, the package or no? Do you want to projecting in the whiteboard the package that we are doing?
Yes, please.
Okay, let me try. Let me try. Here you go.
Professor, for the test,
Uh-huh.
do we send you the photos of our work through email or on Blackboard?
No, email. You send me to me by email.
Okay, thank you.
Okay, we are working this page. Do you see what page? 11 question?
Yes.
Excellent. Now let's do number 12. Number 12 is, well, is f of x is equal 8 x to the a power degree a minus 4 x to the 7 power plus x to the 6 power minus 4x plus 8. Well, so you analyze the number of the change of sign that we have in this polynomial. If this is positive, negative, this is negative, positive, this is positive, negative, and this is negative, positive. Total we have 4. P is equal 4. P is equal 4. And the number of positive is 4, 2, or 0, because you subtract the 4 minus 2 is 2, and 4 minus 4 is 0, no? So we have 3 possibilities. Likewise, to analyze the number of the real negative, you make a reflection. And the reflection is that the even exponent stays the same, doesn't change. However, the odd exponent change the sign. Is 4 x to the 7 power plus x to the 6 stays the same plus 4x change plus 8. You see that we have no change of sign because everything is positive. Therefore, m is 0. Okay, so in my table, well, no, actually we can answer the question. No? The question say degree 8 is this exponent, degree 4, 2, 0, 4, 2, 0, positive 0, and 1. No, 1 no. 4, 2 is no negative. It's the option B. It's obvious it's option B. Clear? Easy or no? Easy Descartes rule? Yes or no?
Yes.
Let's move into 13. Okay, 13 say one polynomial is given again. Okay, it's too long. Wow. F of x is equal x to the 6th power plus 4x to the 5th power plus 4 again, x to the 4th power plus 3 x to the 3rd power minus x squared minus 5x plus 2. Okay, you count how many sign change we have. This is positive, 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 positive. No change here, negative, negative, no change, change 2. P is 2. Si P is 2, it's because the number of real positive is 2 or 0. Now let's do a reflection. F and negative x. You change the only the odd. The even no stay the same. If this stays the same, this is change. This stays the same. This is change because it's 3rd power. And this stays the same because it's even. And this change because the 1 is odd. And 2 stays the same. This is 2. Okay, super. Now analyze how many chain of sign we have. We have 1 here, positive, negative, negative, positive, positive, negative, negative stay, 1 change, and no more. 1, 2, 3, 4. N is 4. See, N is 4. The number of negatives real are 4, 2, 0. Okay. Those degree 6. Positive is 2 and 0. The option D again. Got it? Easy. Sure? No problem with the Descartes rule. Do you understand very well?
Yes.
Excellent. Okay, let's move on to determine the rational potential zero of the polynomial, no? Entonces, remember, it's plus or minus p divided by q. Okay, who is p, who is q? Suppose 14 say 14 f of x is equal 6x to the 4th power plus 3x to the 3rd power minus 4x to the 2nd power plus 2. And the formula is plus or minus p divided by q. And who is p? This is p. And who is q? This is the q. So p is the coefficiency en que the power is 0, x to the 0. O sea que do not depending of x. And q is the leading, que the higher power. Actually, p is 2, entonces you break it down and multiply 2, que es plus or minus 1, and plus or minus 2. And 6, no, 6 is more complicated, it's plus or minus 1, plus or minus 2, and plus or minus 3, and plus or minus 6. So that one easy way to do this is, if you multiply like that, is 6, and you multiply like that, is 6, right? Get the number in the bottom, 6, q is 6. Okay, now the combinations. You summarize in one list. The list of the potential rational zero is, well, is 1 divided by 1 is 1, plus or minus 1, plus or minus 2. So I'm using 2 in the top and the first in the bottom. Now it's plus or minus 1/2. And 2 divided by 2 is 1, but I have here. I don't need to repeat. Entonces, the second is plus or minus 1/3 and plus or minus 2/3. Okay, it's 1/3, 2/3. Comma 1/6, comma 2/6 is 1/3. No necessary repeat again this. Entonces, the answer is plus or minus 2, plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 2/3, and plus or minus 1/6. Okay, the option. I suppose que es B, no? You help me see I make a mistake, guy. Es B, no? And do okay or no? 1/3, 1/2.
Yeah, it's B.
Okay, super. Do you understand this or not? It's super easy. Super easy. Everyone follow me?
Yes.
Yes.
15. is oh guys, I want to erase this page because I need more space to work. I follow with the review I have in my table, no? I suppose you have in your computer, no? Is f of x is equal minus 4 x to the 4th power plus 3 x to the 2nd power minus 4 x plus 6. Who is P, who is Q? P is 6. Q is -4. Over 4, it doesn't matter. They're -4 actually. But I don't care the sign because the formula says plus or minus P divided by Q. So you break it down. P is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. It's the multiple of 6. And 4 is plus or minus 1, plus or minus 2, and plus or minus 4. That's it. And their combination in the list is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Why not? It's 1 combined with the top, everything in the top. So now the next is 2/1 is 1/2, 3/2, plus or minus 1/4, 3/4, and that's it. Because the next is repeated, you don't consider it, right? Remember that this theorem say that this list is the potential zeros of the polynomial, but the theorem do not guarantee 100% that it's true. So this is one clue to start doing this. You are doing synthetic division several times, until you get the answer, right? Super easy, no big deal. Let's move on to the 16, que es similar. It's another polynomial. F of x is equal 5 x to the 5th power minus 6x squared plus 6x plus 1. P is 1 and Q is 5. Okay, so the formula plus or minus P divided by Q is, well, si P is 1, is the only possibility is plus or minus 1, that's it. And 5 no, is plus or minus 1 and plus or minus 5. Our list is now plus or minus 1, comma, plus or minus 1/5. 1/5. Super clear? Good or not good? That's 16, huh? 16, yeah. One more 17. Guy, any question? This is a review. You ask me any question you have, right? 17 is f of x equal x to the 4th power x to the 4 power plus 24 x to the 2nd power minus 25. Okay, let's do exactly the same, listing the potential rational zero in this polynomial. P is 25 or negative 25, either way, and Q is 1. And plus or minus P divided by Q is, well, 25 is plus or minus 1, plus or minus 5, and plus or minus 25. Because actually 25 have only two factors, 1 or 5, because 5 times 5 is 25. And 1 is 1. Now the list of the potential rational zero is exactly the same, because this is 1, so it's plus or minus 1, plus or minus 5, and plus or minus 25. Done. Okay, super. All right. Any question, guys? No? Easy that part.
For number 17, what would be the answer in the review?
Answer is, let me see, I suppose means que es B. Plus or minus 1, plus or minus 5, plus or minus 1/5. Hey. Wait. Entonces I make a mistake. Okay. P and Q. P is 25. Q is 1. Oh, something is wrong here. Wait. Something is wrong. Ah, but I copied wrong, no? Oh no. If I, yes, I copied wrong.
Right.
Look, I copied wrong. Look. I copied wrong in my paper. Hello. Okay, and the original, we have 5 here. Yes or no? 5 here. Yes or no?
For 17?
17? Ah, no. Ah, yeah. Okay, 17, no. 17 is factorization. Wow. 17 is not rational. Psst. Hello. No. Mistake, double mistake for me. 17, you should do another thing. 17 is factorization. Ah, it's easy, look. 17 is no plus or minus P over Q. No anymore. The polynomial is x to the 4th power plus 24 x to the 2nd power minus 25. Oh, it's easy, the factorization, because it's trinomial. And you open two parentheses, no? And you put here x squared. Where come from x squared? X square root x to the 4th power. And the combination is obvious, it's 25 and 1, no? 25 and 1, because 25 times 1 is 25, and 25 minus 1 is 24. How do you know it's minus? Because we see here negative sign. So at least one guy is positive, another guy is negative. This is positive, and this is negative. And we finish? No, we continue because I can see that we have here a differences of the square. It's important to understand that the difference of the square is factorable expression is something like that. It's a very well-known formula. However, the sum of the square, no, is prime. We cannot do that, at least in the real field. So this factor stays the same because the sum of the square, but this no. You break it down into 1 plus or minus. So the answer for the 17 is D. Of course, D. X minus 1, x plus 1, and x squared plus 25. It's D. Everything okay, miss?
Yes.
Okay, super. Well, 18, there are many ways to do that. Okay, you factorization, but not always is possible factorization using the traditional way. And then you can factorization using the synthetic division. So when you face this kind of problem, you have no idea. You are lost. Entonces now I propose you que yo investigue plus and minus P divided by Q. No explicit say the problem that, but this is the one idea, or one fantastic idea, in my opinion, is you put the equation of the polynomial in decimals. In decimal, you discover what is the real zero, positive or negative. And you verify after that use synthetic division. Let's do it in that way. Suppose que I put in decimals. Wow. Y I saw que positive 2 and negative 1 is a good candidate to be solution of this. Okay, to say now you perform synthetic division. 1, 2, negative 5, negative 6. And you divide by 2. This is verification, double checking. Okay, the thing I saw in decimal is correct. Bring down 1, 2, is 4, is 8, is 3, is 6. And when the remainder is 0, that means that the factor x minus 2 belongs to this polynomial without factorization, magically. So of course, in decimals, I can see something like that. Look, n2, positive 1, 2. The function starting 0. The aim behavior for this polynomial look like that. And 2 cross. And negative 1. Now let me see in 2 cross. And negative 1. And negative 3. Is it 2? And this is the picture. Okay, it's a little bit so in decimals. You try it too. Got it. Negative 1. Let me try. Entonces, bring down 1. Negative 1. This is 3. This is negative 3. 0 again. Okay, entonces I confirm que the factor x plus 1 belongs to the polynomial. And that's it. Stop, because I'm so clear that this is x to the 0, is x to the 1, and the factor x plus 3 is also of the polynomial. Entonces, the factorization, without factorization, guys, is the multiplication of this, everything, is f of x is equivalent to, say, x minus 2. The order is not important, because it's the problem. X plus 1, x plus 2. Do you understand this very well or no? Okay. Okay, this is when you have no graphic calculator or decimals 10 years ago. Entonces you lost time to verification, different number. No. You put in decimals. You have the idea how it look like the polynomial graph, and you take the real zero, positive or negative, and you perform the synthetic division to verification, que actually is a factor, using the zero factor theorem. So es a factor when a remainder is 0. Si es not 0, no factor, guys. Okay? Everyone follow me?
Yes.
19. It's super easy. Using technology, of course. F of x is equal 5 x to the third power minus 24 x to the second power minus 9 x plus 20. This is our polynomial. I investigate. I put in decimals again. Yeah, I discover in decimals que at x equal 5 and also at x equal negative 1 is a 0. Pero hay verification. I need to verification. Okay, so you are doing synthetic division. 5, negative 24, negative 9, and positive 20. And you divide by 5. Bring down 5. 5 times 5 is 25. This is 1. 1 times 5 is 5. It's a negative 4. It's a negative 20. Good. Excellent. Zero remainder. That means the factor x minus 5. Remember, in the factor, we have opposite sign to the value. The idea is clear because the value is you take x minus 5 equal to 0 and you solve for x. This is the 0 and this is a factor. Okay? Now negative 1. Si es negative 1 here, let's see what happens. Bring down 5, negative 5. This is negative 4, this is positive 4, 0 remainder again. So the factor x plus 1 belong to the polynomial. And the last factor is, look, this is x to the 0, this is x to the 1, is 5x minus 4. And the factorization, without factorization, using only synthetic division of this polynomial is x minus 5, x plus 1, and 5x minus 4. Fantastic. I like that. Any question? That was 19. 19. Okay. May I erase the board or no? Yes or no?
Yes, you can erase it.
Okay. 20. 20. Okay. 20 is f of x is equal x to the 4th power minus 3x to the 3rd power plus 5x to the 2nd power minus x minus 10. Entonces en décimos I see some zeros like x equal 1, like x equal 2/5, okay, 0.4, because in decimal I see in decimal. And that's it. So let me try with this. I don't know. We have another factor, no? Because actually we have 4 degree. We have 4 factor or no, because maybe sometime we have irreducible quadratic, you know? But I have no idea. Let's do this synthetic division. This is 1, this is minus 3, this is 5, this is negative 1, and this is negative 10. And you divide by 1. Okay, it's easy. 1, and then 1. Wait a second. It's 22. No, it's 20. Ah, I make a mistake. I copied wrong. Let me erase everything. Okay, 20 is 5 x to the 4th power. The problem is I have 2 pages. We look at 2 pages. Entonces x to the 4th power 5, 20. The polynomial is 20. 5 x to the 4th power minus 7 x to the 3rd power plus 22. Wow, good now. Square minus 28x plus 8. Okay, entonces en décimo I see que the zeros are x equal 1, at least the real 0, 1 and 2.2/5, que es 0.4. Okay, let's do the synthetic division. Synthetic division is 5, negative 7, 22, minus 28, and 8. and I try 1. Bring down 5 is 5 and negative 2 is negative 2 is 20. 20 times 1 is 20. This is minus 8 times 1 is negative 8, 0 remainder. Therefore, I investigate the factor x minus 1 belongs to the polynomial. And the other guy is 0.4. So I propose you put like a fraction like that. Bring down 5. And when you multiply this and this is 2. So 2 over 5 multiplied by 5, cancel out the 5 is 2. This is 0. 0 times something is 0. And it's a 20. And 20 times this, let me see, 2/5 times 20. So big is 8, no? Because simplification here 1, 4 times 2 is 8. 0 again. Then the factor is x minus 2 over 5, no? Something like that. We have 2 more factors, but stop because I don't see any other 0 in decimals, no? So this is x to the 0, and this is x to the 1, and this is x to the second, no? Actually, my final polynomial is 5x squared, 0x, so that part is missing, plus 20. Actually, it's 5x squared plus 20. Okay, so how you write that? Well, you write like that. You write like the multiplication of f of x is equal x minus 1, x minus 2 over 5, and 5x squared plus 20, but in my opinion, it's much better factorization in this part, the 5. So you put x minus 5 minus 1, x minus 2 over 5, you factorization 1, 5, and you have x squared plus 4, no? And why no? This 5 you multiply by the this is, if you leave it like that, it's okay. However, this is cosmetic part, no? If you multiply by 5, here is x minus 1, 5x minus 2, and x squared plus 4. Entonces this is the answer, but this factor is irreducible quadratic because the factorization in the real field is impossible. In the complex field, yes, but in the real field, no. So x squared plus 4 and the complex, you factorization like that, look. xx, 2i, plus or minus. It's the same formula of the difference of a square, but in this case you use an imaginary number, right? Actually, this polynomial have 1, 2 real positive, 0, and 2 complex. And the complex is coming by pair of conjugate, plus or minus 2i. But it's not important. The important is this information. And leave it like that, using irreducible complex. It's perfect express. Do you follow me, guy? Any question about the irreducible? Do you understand why? Because the sum of the square is prime. And the real field, leave it like that. And the complex, so you see specification. I want the factorization. And complex field, well, okay. You copy this guy. You copy this guy. And instead of this, you copy this and this. And the complex. But in the real, no. In the real, this, no. I copy that. Clear?
Clear.
21 now. 21 now. 21 is another polynomial degree 3. It's plus, no? 21, yeah. Ax squared. Plus 19 x plus 12. That question say, solving the equation in the real number system. So basically, the answer, okay, 1 and 21, 22, and 23 is not the factors, you know, it's the zeros, but the real zero. See, we have complex, no. I don't include it in this. In this example, in all example, I say, no, I want everything. And you include real and complex. When again, I saw in Desmos que at x equal -1 and x equal -3, we have 0 of this polynomial. Entonces, the only thing you should do is verification using cited division. 1a 1912. And divide by -1. Bring down 1, -1 is 7. 7 times -7. This is 12. And 12 times -1 is -1. Fantastic. 0 remainder. Factor x plus 1 is a factor of our polynomial. One more. -3. -3 is, bring down 1, -3, +4, -12. 0 remains, therefore the factor x plus 3. And the third factor, because the degree is QB, 3, degree 3, is x plus 4, no? And the factorization of this polynomial is x plus 4, x plus 3, doesn't matter the order, x plus 1. And the zeros, es obvio que es -4, -1, and -3. Now let me see, like the option C, no? Option C in the review package. Okay, that was 21, no? Yeah. 22. I want to erase the board. 22. 22 is, the polynomial is x to the 4th power minus 3x to the 3rd power plus 5x squared minus x minus 10 equal to 0. Entonces I need to investigate the real. Entonces I saw in Desmos que the real, que the only possibility, o sea, gráfica you see only real, imaginary is invisible, es at 2 y a -1. Entonces degree 4, I have no idea, the rest, no idea. Okay, let's do it, scientific division. 1, -3, 5, -1, -10. Divided by 2 first. Doesn't matter, the order is not important. 1, 2, -1, -2, 3, 6, 5, and 10. Good. The factor x minus 2 below of the our polynomial. This is the verification of the idea I saw in this one. But -1 is 1, is -1, is -2, is +2, is 5, and -5. The factor x plus 1 belongs to the polynomial. And it's a verification. And the rest is x to the 0, x to the 1, x to the 2, que es quadratic. Because 2 plus 2 is 4, because the degree of the polynomial is 4, is x squared minus 2x plus 5. Okay, by the way, this is another irreducible quadratic expression. If you want verification of this, it's easy. You put equal to 0, Of course, it's impossible the factorization in the real field, but you apply the quadratic formula, no? A is 1, B is -2, and C is 5. I'm plugging it into the quadratic formula. And let's see the 0, que I expecting que es complex. Ok, entonces 2 plus and minus square root -2 square minus 4 times 1 times 5 divided by 2 times 1. This is 4, it's a 20, it's a -16, and the square root -16 is 4i. It's a 2 plus or minus 4i divided by 2 is 1 plus or minus 2i. Actually, the factorization in the real field of the our polynomial is x minus 2, x plus 1, and x squared minus 2x plus 5 is irreducible quadratic expression. So you want to listing, because they want the real 0. Well, the real 0 is only 2 and -1. This is the answer. 2, -1, or -1, 2. -1, 2, -1, que es the option A. This is clear? So you want, for example, factorization and the complex field is x minus 2, x minus 2, x plus 1, open two parentheses, you have xx minus minus, and inside here we have 1 plus 2i, 1 minus 2i, a complex field. Okay? 23. Guys, do you follow me? Do you see easy or complicated that part?
Professor, I have a question.
Go ahead.
I don't understand how you get the numbers decimals and then you say x equals 2 and x equals -1.
Let's do it for you and decimals. Okay, we are doing number 22. 22. Look, you open decimals, miss. Let me try. Are you familiar with the decimal? Are you familiar?
Yeah, kind of.
No, you have to practice. This is super important tool. Okay, this is decimals. Let me share the screen. Screen. Skype. Switching to the another decimals. I suppose you see now decimals. You see or no?
Yes, I see it.
So you here you put y equal. Let me using the keyboard of decimals. Y equal. You put x to the 4 power, x power 4. Minus 3, x power 3. You have to practice. Plus 5 x squared minus x minus 10. Wow. And you see that polynomial. Wow, look like parábola, pero no, actually it's no parábola. Entonces now, amazing, when you click on the curve, you see a gray points. Que is this? Que es 2 and -1. And this is my famous real zeros. Can you put in the center division? Good or no?
Oh, okay, I get it now. Thank you.
Let's do it by curiosity. The next one. Yeah, you open decimal. Let's do it in decimal. In decimals. Okay, this I delete that. Okay, and next 23 is y equal x to the 4 power minus 5 x to the second power minus 36. Wow, look at that, the zero. The real zero is 3, positive 3, and negative 3. And this is the thing I put included in the scientific division. But in this case, no, it's easier because by factorization, remember, the factorization, we can do that using the traditional factorization that you see before in your intermediate algebra class or in college algebra, no? Depending on the subject, you see that part. Wait a second. Switching to screen. There you go. Okay. Look, in 23, I know it's positive 3 and negative 3. However, in this case, no. Not necessary to do it in this way because look, this is easy. You have that 5. Do you see the whiteboard, right?
Yeah, we see it.
Oh, is it, what is it? This dot. Okay, entonces the factorization is super easy. Look, open two parentheses, x squared, and this is 9 and 4 because 9 times 4 is 36, 9 minus 45. The sign is negative and positive. And this is different of a square, and the factorization is 3 and negative 3. And this is the negative 3 and positive 3 you see in decimals. And the other you don't see in decimals because it's irreducible quadratic. The answer for this problem is x equal 3 and x equal negative 3. More clear now, miss?
Yes, I get it.
Move to 24. 24 is, well, 24 is only possibility to do 24, 25, and 26 is graphically. It's graphically. Let me show you. So this is the equation has solution R and the interval indicate. Approximate the solution correct into decimal place. Okay. So the only possibility for solving this problem is graphically. I suppose in the test I put one question like that, similar to this. Entonces, let me try. Again, we come back to decimals. Okay. Okay. Let me delete this. Now we focus it. Look, we focus it. Do you see decimal? Guys, do you see? Yes or no?
Yes, we see.
Okay, x cubic 3 minus ax minus 3. Okay, this is polynomial have 3 0. 1, 2, 3. However, I want to focus in one specific interval. To focus in one interval, I recommend that you open in your keyboard, you open the restriction case, this curly bracket, and you specification the interval you want, get negative 1, less than or equal x, less than or equal 0. And you see one piece of the polynomial. And it's obvious que the 0 is this guy. Que the answer is negative 0.382. Is the option C in our problem. Do you see? See you done specification, the interval you want to analyze. Let me copy and paste. Control C. Control B, paste. You do a specification, you have the graph of the hour complete polynomial. However, The specific part I want to analyze is this. And the zero is this guy. Clear or no? Yes or no? Okay.
So is the answer D?
The answer is C.
C? Okay.
No, es D. You're right. Porque es negative. Yeah.
Okay.
Okay. Entonces, si es clear, well, the rest is easy. Let's do it in the, okay, let me put it, well, no, delete. Okay, next is 25. X to the 4th power minus x to the 3rd power minus 7 x to the 2nd power plus 5 x plus 10. Something like that. However, I want the specific, look, you click here in ABC, and this bracket is the bracket we need. So the interest is minus 3, less than or equal, x less than or equal, negative 2. Wow, this specific piece, and the zero is negative 2.236, que es de option C, que es negative 2.24. Okay. So definitely, when the zero is decimal, it's very, very complicated. Try to find using scientific division. No? This is the one possibility, this graphic. Do you understand 25? It's easy. Let's move into a 26 or no? $25. 26. Let's do it 26. 26 is x to the 4th power minus x to the given power minus 7 x to the 2nd power plus 5x plus 10. Wow, it's similar. No? It's the same. Wow. It's the same. The only thing it changed was the interval plus 10. I redo again. Okay, and the interval is in between, let me see, in between 2 and 3. So 2 or less than or equal x, less than or equal 3. Boom. Well, in this interval, we have 3 guys. No, 3 no. We have 2. Actually 2. But, okay, pero this is less than. Entonces, don't include 2, incluye this, que es 2.236. 236, que, pero es positive, es de option D, I guess so. Good or not good? No problema. This is the question, that question you are doing using decimals. Anytime.
So it's not the first point because of the fact it was less than?
Exactly. This is the idea. You see que the interval is given is not equal in 2. That means que 2, this is the endpoint is excluded the solution. So basically, this is the reason. Okay, let's move on to the whiteboard again. Okay, do you see that? Okay, 27 is more interesting. 27 is, 27 is, well, I need to determine for a polynomial f of x with a real coefficient given by the degree and 0. And the information is given is degree 3. Okay. And the 0, the collection of the 0 is 1 real and negative 2. And 1 complex, que es 3 plus I. Immediately, you need to know by memory que next complex 3 minus I is a conjugate. So this information is not given, but you need to know. Now you are doing the multiplication of the 3 factor, but you are doing in this order. Multiplication of the complex first. So actually, the thing you should do is x plus 2 times x minus 3 plus I times x minus 3 minus I. In either order, but this is crazy. Much better doing in this order, this and this first. And you see why. So you copy down x minus parenthesis 3 plus I times x minus parenthesis 3 minus I. And you FOIL. This is x squared. This is minus 3 minus I x. This and this is minus again 3 plus I x. And this is plus, because negative and negative positive, 3 plus I times 3 minus I. So far it's okay. Now we focus in the multiplication. 2 complex is very, very interesting. Because when you multiply 2 complex numbers and they are conjugate, the answer is always real, no imaginary anymore. And the shortcut to do fast is 3 times 3 gets 9. Always plus. It doesn't matter if it's plus or minus. 1 times 1 is 1. The answer is 3. Okay, suppose you don't know the shortcut. Okay, no problem. You are doing by FOIL. 3 times 3, 9. 3 minus I is minus 3I. I times 3 is positive 3I. And this is minus I squared. 100%. I guarantee you the imaginary part is gone. In this specific problem case, multiplication 2 conjugate. And negative 1 is I squared is negative 1, another negative you have in the front is positive. And you get the same answer. And this is 10. And this is easy because it's x squared minus 3x plus ix minus 3x minus ix plus 10. Okay, it's obvious que the imaginary part is gone. It's cancelled out. I stay only x squared minus 6x plus 10. And is the final answer? No. I need to multiply by x plus 10. So I did the complex part because the complex part magically happened que the imaginary part disappears. And the rest is okay. FOIL, or multiply FOIL in different stages. X cubed. This time this is minus 6x squared. And this time this is plus 10x. And this is plus 2x squared. This is minus 12x. And this is 20. And we combine like term, and that's it. X cubed. This and this together, let's say, no, this and this is minus 4. And this is minus 2. Plus 20. Final answer. This is our famous polynomial that satisfies this condition. The 0 is negative 2. And the 0 is 3 plus I. And another conjugate is 3 minus I. Any question? Super good or no?
Okay.
It's good.
Okay, 28 is a little bit more complicated because 28 include degree 4. And we have two real is given and one complex is given. 28, sorry, not 24, 28. In 28, we have degree 4. So we need to discover what is the expression of the one polynomial que satisfy that condition. Zero's real is -1 and 2. And we have one complex is 1 minus 2i. Therefore, I infer que another complex 1 plus 2i is a conjugate. And the conjugate by definition is the same number, but the imaginary part have opposite signs. The real no. The real stay the same, imaginary change. So I know very well this. Yeah, I perform the multiplication. Let's doing is x, no, black color. Is x plus 1, x minus 2. Bracket. I put the bracket because it's more complicated. So there will be single brackets good. 1 minus 2i times x minus 1 plus 2i. And in this case, I separate the problem. Look here. I do this foil super easy. And this foil gets no easy, it's complicated. But it's okay. It says x squared minus 1 plus 2i x minus 1 minus 2i x plus the multiplication of this number and this number is fine. No? Remember the shortcut. 1 plus 2i times 1 minus 2i, 1 times 1 is 1, and 2 times 2 is 4. It always positive in between. And 1 plus 4 is 5. Entonces es x squared minus x minus 2i x minus x again plus 2i x plus 5. Okay, that part is cancelled. X squared minus 2x plus 5. And this is the trinomial que corresponde with the multiplication of the imaginary part. The trinomial multiplication on the real part is super easy. It's x squared minus 2x plus x minus 2. When you combine like term, it's x squared minus x minus 2 minus x minus 2. And now multiplication both. This is x to the 4th power. So we have 3 times 3, 9 combination of 1, 2, 3, 4, 5, 6, 7, and 9 combination. A and 9 combination. X times x, x to the 4th power. This and this is minus 2. X to the 3rd power. I multiply the first time everything in the second one. Plus 5 x squared. I did the first. Now the next is minus x is minus x cubed plus 2x squared minus 5x. Okay, the last one is minus 10, no? Minus 10. Let me see. Wait, the last one. No, the last one is minus 2x, no? 2x squared. Okay, minus 2x squared. Yeah. Plus 4x minus 10, no? Okay, now who is like? X to the 4 stay alone. Who is like? This is like, and this is like. This is -3, no? Beautiful. Minus 3 x to the cubed power. Who is like? This is like, this is like, and this is like. But by coincidence, this is cancelled out and stay 5. This is plus 5 x to the second power, and this is -1 because this and this together is -1 minus 10. -1 x, so minus x. Minus 10. Something like that. Okay. I suppose que you understand very well, no? Okay, number 21 is the same stupid thing, right? Because I propose you. It's too long. Package. Let's do in 29. Why not? 29 is very interesting. Okay, the 29 is. We have 5 minutes. Let's do in 29 and also select either. Maybe 30. Maybe 30 is good. Okay. 29 and 30. That's it. 29. 29 is. Okay. The factor in 29, wow, it's pure imaginary. So the pure imaginary say is 4i and negative 5i. Entonces the multiplication is x minus 4i, x plus 4i, x minus 5i, and x plus 5. Entonces when you FOIL this, of course, separately, this part, it's obvious okay, this is x squared plus 16. Makes sense, you know? Wow, easy. And this is x squared plus 25. This actually is too, too reducible. Entonces, finally, multiplication. This is x to the 4th power plus 25 x squared plus 16 x squared plus 25 times 16 is 400. Entonces x to the 4th power plus 41 x squared plus 400. It's the answer. Wow, fantastic. I like that. And now 30 is different because 30 is giving not the 0 and you format the polynomial. No, it's given the polynomial and you do the factorization, but in this case they want that you are doing in complex field. Okay, be careful with the question, si es complex field or real field. Dice all zeros of the function and write the polynomial as a product of linear factor. What means linear factor? No quadratic irreducible. No. Entonces 30 is x to the 4th power plus 34 x to the 2nd power plus 2225. Entonces I know que 2225 is the multiplication 25 times 9. And somehow 25 plus 9 is 34. So the factorization of this is x squared, and the combination que open the door is 25 and 9, because 25 times 9 is 225, like this number, and 25 plus 9 is 34, exactly like the middle term. This is the combination que open the door. And both signs positive. And they want in the way, no. Why not? Because they want in the question say linear factor, no quadratic. And you break it down in complex, like that. X. That's mean linear. Why linear? Because the degree is 1. 5i. 3i. Que is the square root of this guy. Plus, minus. End story. Do you understand or no? Okay, entonces stop. That's it. Let me recall something. Okay. This is the first chapter. Tuesday we start new chapter. And Tuesday is do both tests. Test number 1 in Alex and test on paper que I send by email. Is their class on? Of course, their class. We start new chapter, but it's due Tuesday at midnight. At midnight, do everything. Tuesday we start. Tuesday we start new chapter.